One of the best things I like about exponential medicine, it's really a special sanctuary for all of us who are visionaries and maybe even consider a little bit of a unicorn at our institution, sort of a herd of unicorns, if you can say intellectually. So very grateful for Daniel to have started this in the first place and really spurred me on to chase my dream and vision of developing an expertise and experience with artificial intelligence in medicine. So a little bit about sort of my bio on one slide, basically. So I'm a practicing pediatric cardiologist. I was head of the heart program for a long time. And it dawned on me for about a decade that a lot of what we do and a lot of what's being said in conferences as clinicians are not necessarily entirely founded on not just evidence, but data. I'm just curious, how many people here are active clinicians? Okay, so this is an amazing number. So you can understand what I'm talking about. So February 14, 2011, the night that the supercomputer from IBM beat the human contestants on Jeopardy, was the night I realized artificial intelligence was here in a big way. And that was the night that I downloaded the application for the Stanford data science program. And so that was quite an epiphany. So going back to school as a senior physician with my classmates a third to half of my age, what does that feel like? And you can imagine the computer science capabilities of the younger generation at Stanford. I told my CEO was like being an average athlete at best, and now I'm competing with the Olympic Russian hockey team on a daily basis. I'm on the ice, I got the skates on, but that's about it. So for those of you who are thinking about such a career, it's absolutely worth the journey, because as hard as it is, it's amazing what you learn in a very short time. So I'm a clinician, so I just want to talk about my day-to-day right now and where the pain points are. So when I see a patient, this happened last week, I look at the echocardiogram since I'm a cardiologist, try to remember what the last echocardiogram showed, sometimes going back to the last study, get some data, and encourage parents to give me data. So this is what I sometimes get. You can tell that some of the readings are taken during breakfast time because there's a coffee stain in the upper right corner. And prescribe the same medication, right, to all of my heart failure patients, for instance, at the same dose. And then, because I'm so into follow-up that sometimes it's just a simple text on my iPhone. So this is 2016 with all the technology that you've heard about today, and we'll be hearing about in the next few days. Why are we not further along in a typical clinical setting? This is what we're about to launch next month at Children's Hospital Orange County, something called what I call an intelligent clinic. So we're trying to leverage the technology and artificial intelligence and the analytics into our daily practice. You've heard great things about technology and what's available, but how do we distill that into a day-to-day situation is the hard part, by the way. So we're going to have wearable technology for vital signs. Ideally, we're going to look into having the echocardiograms actually machine learned and read in conjunction with the cardiologist's interpretation. So that's something that's not done routinely, but hopefully we'll see that within a decade. All the patients will have not just genomics done on their cardiomyopathy, for instance, but pharmacogenomics, so that we know which medicine and what dose would be best with that particular patient, which is not typically done, as you know. And then there will be compliance will be measured with a sensor technology that's readily available. And lastly, we're going to have an AI-inspired educational avatar for all the questions and the nuances that come up between visits. So we want to build a continual experience for our patients' families. So what is it going to take for this to happen in the near future? Three things I'd like to leave with all of us. First, we have to look at the cultures of clinicians and the computer and data scientists and how different they are. Now, having embedded myself in the Stanford culture of data scientists, computer scientists, and now working with a data scientist team or startups, I think it's amazing how few times the data scientists actually understand physician culture. So we're sort of educated on evidence-based medicine, when in fact the world is changing into what I call intelligence-based medicine, where you have to dig data deep by writing algorithms and getting data from EHR, as well as other types of data. So the world's changed, and the physicians are not always cognizant of that. The second aspect of the culture of physicians is, yes, we have a little bit of hubris. We simply can't accept the fact that a machine can perhaps read an MRI more accurately and faster than we can. No matter how many times I talk to radiologists about this, there's always a pushback. And we should accept the fact that this is a great opportunity to improve what we can do and take a lot of the burden off. And that's the part I think the physicians can do better. Prestigious journals like the New England Journal of Medicine has not even mentioned machine learning. This is a review article or editorial that literally came out this week on machine learning for the first time. So if you Google or PubMed search machine learning and JAMA or New England Journal, there's a paucity of articles on this topic. So no wonder physicians are not well read on this particular topic. And then the sense of competition, right? Hospital to hospital, there's really little sense of sharing data that the data scientists have and have open source software. So we're used to competing, not collaborating. What if we look at the flip side with the data scientists? Most data scientists would love big data, and sometimes I think is just as important is look at the limitations in medicine to have big data and concentrate on something I call small big data, which is looking at one individual's patient's data or big data. So that's what I call small big data, and that's something that I think data scientists can hopefully in the future appreciate a little bit more. They're always focused, or mostly focused on decision support, right? That's what they think helps physicians, when in fact sometimes what we need help with is just workflow, efficiency, and access to data in a timely fashion. And I like the data scientists sometimes to focus a little bit more on that. Also, correlation doesn't mean causation, and that's something that the two cultures need to reconcile. And lastly, what I like about the data scientist world is there's wide open collaboration. This is the number of available. Neil talked about R software before. Most physicians have not heard of R software and probably not aware that there is tremendous increase in the number of open source codes that are available on the internet. So in the future, I think both cultures need to clash more together and in a very productive fashion work more closely with one another. It's rare that you have a data scientist team work very closely with physicians. It's also very unusual for physicians to have a data science background or work actively on a day-to-day basis with data scientists. So I think both cultures have a lot of ground to make up in terms of understanding each other and reconciling the differences between the two cultures. The second aspect of this is the data aspect. And we're at the presidential election time, and one of the very famous bylines in a previous election was, "It's the economy, stupid," right? You probably remember that. And I like to say it's the data. It's all about the data. The AI part is actually relatively straightforward and pretty far advanced in AI right now. If you think about it in the terms of classical music periods or music periods, think of the AI outside of medicine as sort of in the Baroque period, getting into the classical period. In medicine, we're still sort of in the medieval period. We're still struggling with use. And of course, that to have good intelligence or AI application, you need really, really good data. What's happening in healthcare and data? Again, most physicians I talk to think about AI in healthcare as sort of the robot. And I know we had some great talks on the robot, but it's not only about the robot, right? So it's also about AI in the sense of a special resource or energy that's going to be illuminating all the dark areas in medicine. So it's not only about the robot. The robot has some applications in AI in healthcare, but it's not the only application. What's happening in data? There's so much missing data in healthcare that there are actually books written on this topic, missing data in healthcare. I knew that firsthand because I had a lot of homework assignments to do in the Stanford program, and as good as their database is at Stanford, oftentimes at least 50% of the data cells are missing when we do a project. At least 50% of the data sometimes are missing. Unstructured data is our problem in healthcare as well. These are beach stones north of here, and it reminds me of healthcare data. This is a sign-out note from one of our nurse practitioners, and you can see that there's a lot of information there, but it's very, very unstructured. Now, thankfully, with natural language processing, or NLP, we're going to be able to solve some of this problem with unstructured notes. But wouldn't it be wonderful if the medical field and the nurses and the doctors can have a rudimentary understanding of structure and data and help to make the data a little bit more accessible? Sometimes I recruit parents to help me with data. This is an amazing family with the dad who's really into data, as you can tell, actually recorded and plotted the pulse oximetry readings for me that actually affected my decision that day to proceed on with surgery for that particular child. So we really can't think of this as a siloed event in terms of using data. We need to get the patients and the families involved as well and organized. Data is escalating. Just reading material alone, the number of articles in the healthcare arena is doubling now every 2 or 3 years, doubling. So it's at a point where no physician is able to keep up. There's also the issue of future data, what I call data tsunamis coming. This is wearable technology. So the data tsunamis are coming, so are we going to be swimming, surfing, or just be drowned by the data tsunami? So it's very, very important that we really take advantage of the data. The main issue I see with data is actually fragmentation. So think of AI as a big rocket that's going to be able to pursue the moonshot projects they hear about in medicine, and think about data as the fuel to help launch these missions. What's happening is that each hospital, each patient is sort of hoarding their little gallon container of rocket fuel, and we're not able to fuel the rocket to go to great distances. So one thing we need to do is really, really get this data fuel together. And lastly, what's been really in the news recently is cybersecurity in healthcare. So a lot of the phobia or the fear is appropriate in terms of security of the data. So how do we get healthcare data in a safe format to be shared, even if there's a willingness to share? And one potential solution in the future, and I think Daniel mentioned it, is using Bitcoin technology or blockchain to help solve that enigma of a problem. So the conundrum in healthcare is lots of data. It's not that we don't have enough data. Is how is the data going to be better structured, better formatted, more complete, and more understood and shared? So the second takeaway I'd like to leave with you is data need to be improved and shared amongst all stakeholders. That will make the intelligence part far easier and far more productive. This is something that we're working on at Children's Hospital Orange County, which is you probably have heard of graph databases, which is a special type of database that we can use in healthcare. Healthcare is particularly well suited for a graph database structure. And even if you haven't heard of graph databases in general, you know it because it's what LinkedIn and some of the dating sites use. So you can say that healthcare is literally a decade behind a dating website, which is pretty sad to me. So this is a hypergraph database format that will be particularly well suited for healthcare because think of it as a three-dimensional structure for a database, which is something that we're not used to seeing in healthcare. The reason why this is important because deep learning, as you heard from the previous talk, is really now in a very robust form. And the way the computer thinks about playing the game Go that you heard about is, to me, very similar to how a clinician or nurse would be making a decision with a patient. So it dawned on me. So the first epiphany for me was the IBM Watson beating the human contestants when I realized that AI has arrived. The second big epiphany for me was when the computer beat the Go champion, and that's when I realized that deep learning is really going to make a tremendous difference in healthcare. And this is basically how healthcare will be eventually thought of, as multiple layers of information and data going from imaging to genomic information, all the omics, EHR, et cetera. So that's then the future of AI in healthcare, which is essentially building a medical brain that will be the smartest and the fastest clinician on the planet in any subspecialty that you can name. So that's our sort of passion and goal, is to build this medical brain so that sometime in the near future we will have most of the answers, if not all of the answers, questions answered in healthcare. This is the number of startups, as you saw earlier. It's been close to 100, and the amount of dollars pouring in from venture capital has really escalated exponentially since we're at an exponential conference in the last year or two. So where is this money going, and how are we going to use healthcare? This is sort of how I divide up all of the AI influence in healthcare conveniently into 6 different areas. I'm just going to summarize what's happening in each of those areas. Decision support is the traditional use of AI in healthcare, and including hospital monitoring. So imagine all the ICUs in the hospitals now have access to all the ICU data from everywhere else in the country or around the world to make a better decision for the ICU physician. And that's already happening to some degree. And again, it's not just ICU data, but it's all the patient's own data in terms of genomics, pharmacogenomics, EHR data, and pooled into a large repository to make a very, very smart decision. And just like Tesla's approach to AI and learning, every mistake will be recorded and analyzed and hopefully corrected when if you happen to be a patient in the ICU setting, or even in a hospital setting. So this is AI in real use. We started something called the Rothman Index, which is an adult application of ICU data to predict readmissions as well as mortality, and this is live use of that data. So Dr. Annis was the pediatric ICU director, can actually think about using that as part of his decision-making process. A huge area in AI in healthcare is medical imaging. If you think about medical imaging, most of the images that you see today have only been around for the last 2 or 3 years. So that's how fast the medical imaging has exponentially risen in the last even 5 years. It's just not going to be possible for human radiologists to read all of the images in the near future. And as you know, the AI or machine learned algorithms have now repeatedly superseded the capability of even groups of radiologists. I would be the first one to tell you, I don't think radiologists will ever be totally replaced, but it would, I think, be a smart radiologist to accept the fact that AI is an ally rather than the enemy. So this is a cute little project I did at Stanford. I'm a cardiologist, so as some of you know, MRI images are great for quality of images, but echo is great for physiology. And in my mind, I always thought, wouldn't it be great if the 2 images could be sort of magically converge? And with a little MedLab help from my computer scientist friends, we actually did do that. So this is a combined image of an echo superimposed on top of a MRI that can be done easily with any programming language and help the clinicians to make a decision. Another big area that you heard about already is precision medicine and drug discovery. How do we individualize any therapy for any particular patient? Not just cancer, but even if you have an infection, most of us are lucky because the antibiotics we get happen to cover the bacteria, but wouldn't it be nice to have a very individual recipe, pharmacological recipe for your infection even. A fourth area is the entire big area of cloud computing and big data. So when we think about AI in healthcare and why this is the perfect time for this area to really blossom and yield dividend, it's what I call the ABCD of AI in healthcare. A is for analytics and algorithms. B is for big data, and now probably add blockchain. C is for cloud computing and cognitive computing, and D is for deep learning. So those sort of elements have really contributed greatly to how AI is going to be an amazing force in healthcare. The most exciting 25 years in medicine are coming up, so I think you sort of feel that because that's why you're here. Digital medicine and wearable technology is pretty much starting. The amount of data that's going to be generated from all of the wearable technology devices is going to be very daunting without some sort of embedded analytics right into the device. So there's Internet of Everything on top of Internet of Things. Internet of Everything implies that there is primitive AI built into the device and not just the connectivity that you hear about. So this is going to be routine for patients in the future to have some skin sensor device that's going to monitor vital signs so that it's going to be imported into a repository and analyzed prior to the visit. And lastly, I think an exciting area is not just robotic technology in healthcare, but the aspect of virtual assistants, smart assistants. So wouldn't it be wonderful if all of us have a healthcare avatar that's going to guide us day to day in our healthcare and make best decisions and remind us of things we need to do to maintain healthcare. The scary thought is for insurance companies to impose this on all of us, some sort of AI-driven, inspired guidance system that if you don't follow, then potentially that can have repercussions on your premium payment, for instance. So I think it's better for us to take control of this and use it and show the value rather than being forced to do so. So again, these are the 6 areas I think are very fairly robust right now in AI in healthcare. The beautiful thing here is just like everything else that you've heard about all afternoon, is these areas are sort of converging and growing exponentially. So the impact of AI in healthcare is going to be, I think it's still being underestimated, just like AI in general has been underestimated all these years. The bottom line about AI in healthcare is you really need humans to drive this process. This is a wonderful group portrait of 25 children's hospitals coming together to collaborate. And we should never forget the impact of the eye-to-eye contact in this digital and AI world, how important that is to drive the process. So intelligence needs to be learned and orchestrated by humans. I just want to leave you with one last parting thought about AI. Again, it's not about the robots. Unfortunately, the media perpetuates this misconception. It's more about a force and an energy, just like electricity, to illuminate the medical world. So one of the residents always has commented that, Dr. Chang, you're trying to replace us with robots. Well, that's not the point. It's to try to make us more human. So I say AI is great because it makes the visible invisible. So the point is not to have the robot. The point is not to have the computer on wheels, but have the AI embedded so that we don't have to see something that's not conducive to patient care. And then the opposite is true too. It's going to make the invisible visible because we're going to be able to data mine and find signals in the noise. So if you're curious about AI in medicine, Daniel is going to be one of the keynote speakers for an up-and-coming meeting on December 12th to the 15th, right up the highway here at the Laguna Niguel Ritz-Carlton. 3.5 days of everything that you ever want to know about AI in medicine with about 50 renowned faculty. So really excited about that meeting and really like to see you join us. I want to just thank the Walt Disney Lund Foundation for giving me this opportunity to pursue AI in healthcare, and my amazing colleagues at Chalk, as well as my very patient mentors at Stanford, probably glad I finally graduated, and my fellow computer scientists at Chapman University, and the many, many special people I met along this amazing journey of AI in healthcare. So thank you very much. Yeah. Thank you.
So one great example, you've been a catalyst yourself. You started now this, we're both pediatricians, Pediatrics
Right.
2040, which is another bringing together of folks.
So the pediatric version of your meeting in
Right.
Exponential Medicine.
And now the iSpy group.
Right.
Which stands for?
International Society for Pediatric Innovation. I know there's a shout out to those of you who are here that belong to iSpy. We're trying to push pediatric innovation.
Great. Thanks, Anthony.
Thank you.
Cheers.